So today I want to talk about Azure Cosmos DB. I just want to get kind of a show of hands. How many here have either done some dev or testing in Cosmos DB? All right, just a few. Anybody running it in production? One guy running it in production? Awesome. Okay, good. So for most of you, this is all new. Other than just the slide you saw like 2 minutes ago about Cosmos DB, would it be new for you? Okay. All right. So here's what we'll go over in today's session. I want to give you kind of a high-level overview of Cosmos DB, kind of what it is, how you'd use it, the scenarios for it. I want to dive into the resource model for Cosmos DB and just talk about the various top-level objects within Cosmos itself. I'm going to spend a little bit of time talking about partitioning in Cosmos DB. This is an important concept to understand when developing and building and running applications using Cosmos. I'm going to talk about a concept we have called request units that's specifically around throughput. And you need to understand request units and how they work and why we use them. Spend a little bit of time talking about indexing. And then I want to focus more time around replication. And I'll talk about a new feature that was just discussed called multi-master. I'll then dive into some new stuff that we've just announced recently at the Ignite conference just last month. And then I want to help you get started. So I'll spend some time going over some resources that we have just to help you learn the product, understand where to go, learn more, and then we can do some QA after that. And that should hopefully wrap it up for, what am I at, 75? 70 minutes, okay. If that gets any shorter, let me know. So what is Cosmos DB? So Cosmos DB is Microsoft's globally distributed, massively scalable, multi-model database. This is really the service that if you're going to build a planet-scale application in the cloud, this is the database you'd want to use. We support multiple models or formats, so we have native support for key value, column family like Cassandra, document databases like MongoDB and our own native document format, as well as support for graph. And we provide wire protocol support as well for those for MongoDB, Gremlin for graph, and then Cassandra. One of the nice things about Cosmos DB, or what makes it what it is just basically the replication. So we have built-in turnkey global distribution for all of your data within Cosmos DB. We also are really built around resource governance. So one of the things about Cosmos DB is you can get elastic scale out of both your storage within Cosmos DB as well as the throughput within there. And I'll talk about that a little bit more a little later. We have well-defined consistency models. So most databases you have like a strong or an eventual. We provide 5 levels of consistency within your databases that you can choose from. We do all of this with low latency, so guaranteed single-digit latency at the 99th percentile and even less at the 50th percentile. High availability, so we're among one of the only services in Azure that provides 5 nines availability for your applications. And of course, all of this is backed up by comprehensive SLAs within Azure. So Cosmos was really built to support kind of the next generation of cloud applications. And there's some really key features that really make this possible. Certainly with being able to distribute your data globally, this helps put the data where your users are. Some scenarios around this would include, say, e-commerce. If users that want to buy stuff out of your application want to do so very quickly, getting that data as close to them as possible is super important. Other applications like IoT or gaming or even fraud detection. Say you're an Experian or a financial services company, you need to be able to see transactions and activity happening around the world. Being able to replicate that data globally in milliseconds is going to be key to understanding what's going on with your customers. Another feature or capability with Cosmos DB or another use case is being able to do analytics over operational data. Cosmos DB has support for Spark in our Spark connector, so you can use that and then light that up to do insights and get insights into your data using Cosmos DB. as well. And then finally, if you're already running a MongoDB or Cassandra workload, either on-prem or in VMs, we provide kind of that lift and shift as well, where you can migrate your data into Cosmos DB, and then using the MongoDB or Cassandra APIs, continue to work with your applications as they were built. So let me dive into kind of the resource model. So this is a bit of a 101 for Azure. So at the highest level, you're going to have an account. And here you'd provision a new account within Azure, either using the portal. We also support PowerShell or CLI to provision new accounts. When you provision the account, you're going to create a new name for it. And this name is going to become a unique global URI for your access to Cosmos DB. And then, of course, similar to kind of how Azure Storage works, at the account level is also where you get your keys. So we support read-write keys and read-only keys, so you can help kind of maintain the different levels of access for your data within Cosmos DB. Within the portal here, you can kind of see, here's the kind of information you would have to create or enter to create your new account. So at the top here, you're going to enter in an ID, and that needs to be globally unique across all of Azure. And then you choose an API, so you could choose SQL or Mongo or Cassandra or table or graph within there. Select your subscription that you want to run it from. You can create a new resource group or use an existing, and then you can select a location or a region for it to run in. So the next layer down from there is the database. And essentially, this is just kind of a logical, if you will, abstraction for containers itself. So databases can have one or more containers. And then within the containers, these are essentially buckets where you put your data. And depending on the model you use, this is either going to be a collection or a graph or a table within Cosmos DB. So here I want to show you kind of the blade where you would create a new container. So here you're going to enter a collection ID or a name of the collection. And then what you need to do is specify the capacity for it, or the storage capacity. So here I want to point out something. So we do a lot of work to help abstract away the physical layers for these things within Cosmos DB. If you're going to build a really massive scale global database like this, and you're going to have terabytes or petabytes of data, you're going to have to deal with things like storage in that. Within Cosmos DB, we really provide that kind of abstraction away from that sort of thing, and the way where it kind of surfaces here is within the storage capacity. So the max size for the SSD disk within Cosmos DB is going to be set at 10 gigabytes. So if your data grows beyond that, then if your data doesn't grow beyond that, you can just create a single fixed size storage capacity within there. And then you don't need to specify a partition key. But if you grow beyond that, we're now going to have to provision multiple disks and multiple physical partitions to store that data. So you then need to specify a partition key to help us find where your data is going to be. The next thing you need to know is, in here, you're going to specify throughput capacity. So these are going to be resource units within here. Now I'll talk a little bit more about resource units a little bit later, but I just want to point that out, that here is where you're going to see some of the logical and the physical kind of surface through when you're provisioning a new account. The next layer in here is the items. And this is essentially where your data gets stored. So all the records, all the documents that you put in there. There's also some other objects that are at the container level that you would define or associate with a container. And that includes things like stored procedures, triggers, or user-defined functions. And then there's a new object called conflicts, and I'll talk about conflicts a little bit later in the talk. So let's go a little into partitioning. So when you're building really large databases, you typically would have to span multiple clusters of machines to be able to store all that data. And this is the model we use. It's a scale out for that. And in Cosmos DB, we manage all of this for you. So let me walk through an example here. So, here I have a Cosmos DB container full of users. And this data is going to be well over 10 gigabytes, so I need to define a partition key. In this case, I'm going to use user ID as the partition key for the data. And what this does is it represents a logical abstraction for the partition of data that you're going to store within there. So behind the scenes, what we do is we create a hash of the user ID and then distribute that data over the hash values to a set of physical partitions where we're actually going to store the data. So when you look at this in practice, here's my contacts database, and I'm using my hash ID. So within here, I've got different users, different user IDs. So I've got an Andrew and a Mike, and then a Bob, and then a bunch of people over here on the right. So within here, you can kind of see here's the amount of physical storage being used by each of the records using these partition keys. And here you can see Andrew and Mike are sharing a single physical partition here over the left. We've got Bob with a lot more data. He's basically taking up all of partition 2. And then I've got these other users on the right. There's not much data for them, so we basically collapse them down onto a single partition here on the right. So what happens then if one of these grows larger? So if I've got, say, Dharma here and Sharish, they're growing too large to sit on that single partition there. So what we do behind the scenes is we will actually move them from one partition into another partition and do this seamlessly. So you'll never see this ever happen. We actually will manage all the physical storage for all of your data within the partitions without you having to do anything. The only thing you have to do is just define the partition key that you want to store the data on. So one of the questions we obviously get then is, well, what's a good partition key for my data? And the answer is, it depends. One of the things you need to keep in mind when you're designing a good partition key is you want to make sure that you're distributing the request across as many partitions as possible. You want to avoid what we call a hot partition. Now the idea for a hot partition, let me give you an example. So let's just say I've got an IoT application. It's a fleet management application. And each of those, I'm tracking the telemetry from each of the vehicles that's driving around every day. And maybe they're delivering, I don't know, goods or something like that, or they could be doing anything. And the ID that I select for the partition key is date. So what do you think is going to happen when the telemetry from all those vehicles starts to write to Cosmos DB? They're going to use the date for the partition key. So now that partition for that date is going to be super hot because everybody's writing to that same partition every day, right? And so every day, the next day, that partition is going to be the hot one. Likely too, if you're running analytics over that data, the reads are going to come out of that same partition, so it's going to be doubly hot because you've got lots of writes going into the same partition, and then the reads are all coming out of the same one. So what's the takeaway? Date's generally a bad idea for a partition key, or at least in this instance it is. Probably a better partition key would be maybe using the vehicle ID. That way each vehicle writes to its own partition, that data grows at a set rate over time. You've got reads and writes generally going off those partitions in a well-distributed way. You can even do something else, like you could create, say, a composite key. So I want to compose a vehicle ID and the date. So you could also do something like that. So the idea here is distribute the writes, distribute the reads, and then just try to avoid these hot partitions within there. Just some of the things that we kind of suggest customers to do. There's really no silver bullet for designing the right partition key for your data. Really the only and the best way of doing this is just building like a proof of concept application and then test it, right? It's really helpful to understand kind of what are the queries that I'm going to be running here in my data, right? What do the writes look like? What do the reads look like? And you don't need to be perfect. Like you can get into some analysis paralysis on this and making sure that I'm accounting for every single query that's running against my database. Generally speaking, if you apply a bit of an 80-20 rule, you should be in really good shape for this. The other thing I want to point out too is our SDKs will actually help you with this. There's actually metrics you can get out of our SDKs to kind of get the cost of what it's doing for RUs within there, which is the thing you really want to measure is the resource usage, and I'll talk a little bit more about that as well. You can also look at Azure Monitor. So we're fully instrumented through Azure Monitor. You can get data through there as well. We also have some sample apps out on GitHub, and I'll kind of walk you to where those things are. But we have some test harnesses that you can use and just apply the patterns within there and then run your test through those, and you can get RUs as well as the latency on your applications within there. So let's talk about request units. So what is a request unit? It's basically a way to represent provisioned resources for your database. And it wraps up physical concepts such as memory, CPU, and IOPS. In the physical world, if you were going to design a distributed application like this, these are things that you would have to account for, right? This would be part of the capacity planning, right? How much data am I going to store? How fast is it going to grow over time? What is my usage going to look like? How many requests am I going to have to satisfy? How fast do those need to go? What we really try to do here is to abstract all of that complexity away from you. I mean, the nice thing about Cosmos DB is that it's completely managed, right? So the only thing you need to figure out is what does my throughput need to be? And then, of course, also how much storage am I going to need? But even in that case, if you select unlimited and use a partition key, we're handling that for you as well. So really, for us, RUs kind of provide that metric for how we manage resources behind the scenes, and it's also key for the SLAs that we provide for the service. So something to keep in mind is not all RUs or not all requests are the same. So a read is going to be less expensive than a write. A read is just simply going to go to the replica and then pull the data back. But if you're doing a write, that write needs to then be sent on to other replicas, and that's going to cost more in terms of RUs within there. So queries themselves will consume different RUs depending on how the query is written, and whether that query can be resolved from a single partition, or whether it needs to scan partitions to go get all the data. So this is another reason why testing on your applications is super important, because you want to make sure that your queries are operating as efficiently as possible and not having to scan multiple partitions. So everything that you do in your database is going to consume RUs in there. And when requests go over the amount of provisioned RUs, you're going to end up getting rate limited. Now, this results when you're calling the database in a 429 getting returned back by the service. Now, if you're using one of our SDKs, like our Java or our .NET SDK or our JavaScript SDK or our Python SDK, we'll actually handle this response for you and then do an automatic retry on that. And in fact, you can configure the number of retries that you want our SDK to do that. If you're using our low-level REST API, then you would have to trap that 429 response that's coming back and then implement your own retry logic, and you can put a backoff in there as well. Another thing to keep in mind is that RUs are spread across partitions. So you can get a hot partition and still end up getting rate limited while you have other partitions that are sitting there completely idle. So this is another thing to keep in mind when you're designing and modeling your data and designing and testing it, is that you are distributing that load as equally as possible within there. So let me talk a little about indexing. So by default, Cosmos DB will index all the data within your collections. You don't need any schemas or secondary indexes within there. If you add new data within your records, we'll automatically index that as well. You don't need to make any changes or do anything. And this works for every model we support in Cosmos DB. So with Mongo, with Cassandra, with Graph, with our own native format, everything is indexed all the time. However, you can customize that. So we support custom index policies. And if you want, you can specify the shape of your index while maintaining that same flexibility within your data model. So what you can do is just specify the type of index you want. And you can see in here we've got a hash, a number, or even a spatial within there. And then write the paths that you want indexed. And then you can also exclude paths within there. So in some cases, you may have data that makes no sense to index. Maybe it's just a wide chunk of data or whatever like that, and you're never going to write any queries over it. Here, you can specify custom index policies, exclude certain paths from being indexed. This will help improve the performance of your application. So now, let's talk about replication. So if you're going to build a global scale application, you really need your data to be as close as it can be to your users. Nothing can travel faster than the speed of light. So even if your application is deployed everywhere around the globe, your data still needs to travel across our backbone. So let's just say you have an application and I've got a web web endpoint in Singapore, and West US, and East US, and Northern Europe. So in terms of the response rate from customers located in those regions of the application, it's going to be really fast. But if I'm doing anything on the data end of things, it's still going to be really slow. So the idea here, and the best thing, one of the best things about Cosmos DB is our ability to be able to replicate that data globally around the world. And replicating data within Cosmos DB is really simple. All you need to do is just add a new region within the portal, and then we'll replicate all of that data for you, and then make it available. So essentially, every action on that data from that point on will happen there locally. So just to kind of illustrate kind of the latencies we're talking about here, I've got an application or a VM that's sitting in West US, and then I've got a Cosmos DB instance sitting in Southeast Asia. So this is sitting in Singapore. And here you can kind of get an idea of just what kind of latency you're talking about. So I'm going to hit the application in West US. That's going to be really fast. But the application itself needs to travel all the way to Singapore to go get the data. And you can see there's quite a bit of latency here involved, generally about 200 milliseconds, just under the best conditions, but it can be even further, way more, depending. Versus this, where I've got an application in Cosmos DB in the same region, so now you're seeing the kind of latency that you would expect, and in fact what our SLAs provide, which is going to be single-digit latency. So generally less than 10 milliseconds at the 99th percentile. So as I mentioned, Cosmos DB automatically replicates all of your data globally. And all these regions are hid behind a single global URI that you use in your applications. This was the account ID that I talked about earlier when you create your Cosmos DB account. Now, when you deploy your applications, you just simply tell the client which region it's going to run in, and then Cosmos DB will automatically use that region to talk to the database. And then if that region becomes unavailable, what we'll automatically do is we'll retry that request on the next closest region. So let's talk a little about consistency models. So as I mentioned before, a lot of databases out there in the market today just provide strong and eventual. Cosmos DB provides 5 consistency models you can choose from strong all the way to eventual. Now there's some serious trade-offs between these, and it's important to understand the difference because all of them have an impact on availability, latency, and throughput. Now obviously on one end of the spectrum you have strong. So in this scenario, all reads are guaranteed to be the latest records. The trade-off, of course, is the higher latency and the lower throughput you're going to get by using a strong consistency model. And then on the other end of the world, you've got eventual. So in that model, there's really no guarantee that you're going to get the latest record, but you do get the lowest latency and the highest throughput. Now you might think, why would I ever want to use eventual for a consistency model? But there's actually scenarios where this is actually okay or it's fine. Let's say you're using or building a social media application where you don't mind when kind of updates kind of come in, it's okay. Or say a leaderboard. An example of this would be like a golf leaderboard, right? So you've got the guy up there and he's got the little things and he's poking them up there, and Tiger Woods just made a birdie on the 18th hole, but you don't see that for a few minutes, but eventually you see the score up there. That's kind of an idea of where eventual is fine as for a consistency model versus say strong. What I would say around the consistency models is most customers will test consistency models for their application and dial it into the one they think is right. Generally, I think about 70% of all of our customers end up using session consistency. And here what that really means is you can read all of your own writes. And basically what that is that's tied to the connection from your application to Cosmos DB. A lot of other customers, or a few more customers, a lesser amount, will use the bounded staleness in there. But I think what's important is that you test these and see the impact on the application, and depending on the scenarios, pick the one that makes sense for you. The other thing I'll point out too is you can also change this and relax it. And you can do this on a per request basis as well. So there may be scenarios where you need to dump a bunch of data and you kind of don't care when it gets in. You just need the throughput or the low latency for that. So you could drop it all the way to eventual if you're at like a session or a bounded staleness, and do that on a per request basis within there as well. Okay, let's talk about the thing I am so excited about. So this was my feature, multi-master. Has anybody, who's not heard about multi-master? Everybody raise your hand. No, everybody's heard about it because they just talked about it before I got on stage. So anyway, Cosmos DB certainly being awesome as a database, right? And one of those things is the global replication. However, prior to this feature, the way that model worked is you had a single writable master database in whatever region you had set it up in, and then every region you added in Cosmos DB was a read replica. So this works great for applications where you have applications deployed in different regions with a Cosmos DB database backing them up in each region, because you're going to get that super single-digit latency within there. With multi-master, now every region is now a full writable master. Right? So what does that mean? That means now you get single-digit latency on your reads and your writes within there. And of course, you get the 5 nines availability for all those operations as well. Now with multi-master, because it's now masterless, we need a way to provide conflict resolution. So we've provided multiple ways of doing conflict resolution within your applications. And really what this means in terms of a value prop is you really get unlimited scalability for all of your endpoints, for reads and writes. And this is really super important. Right now, you can do this in all Azure regions. Is anybody a government customer? Or do government work? God, I would expect more out of this group. I was going to say.
Government contractors.
Government contractors? Okay, so available in all regions, including all the US Gov clouds and all sovereign clouds, everywhere around the world. So Cosmos DB is a Ring 0 service within Azure. So as soon as we light up a new region within Azure, Cosmos DB is automatically there. In fact, there's a lot of services within Azure that are now starting to use Cosmos DB because of all the great features and benefits we've gotten. That this is certainly one of them. So all Azure regions, all data models. This is brand new for things like MongoDB. Cassandra already had this kind of capability. But for MongoDB, this is now available for Table API, for Graph. All the models are available in there. It's also supported with all the SDKs as well, so you don't need to do anything different with your SDKs, or just use the latest ones. So how do you set up, or how do you enable multi-master? So all you do is just go in and create a new Cosmos DB account, enter in your subscription, the resource group, account name, select your API, select a location. Although now, location doesn't really matter much anymore because you're going to add more regions to your databases anyway, so this doesn't make sense anymore really, right? Or it's just it doesn't make any difference. And then select multi-master right here. So just click the little button right here. For you guys off to the side, I'm pointing at the multi-master button. And then click next. So we'll then go and provision your new multi-master account. After you're done with that, you then need to just go and add regions. Where do you want your databases to be available? And you'll notice here, and this is a change in the user interface in our portal, now when you add a new region in there, you have reads and writes enabled for all of them. The other thing I want to point out too is one of the things that's different is you don't configure any failover with this. So because every database is now writable, failover is basically implicit, right? So if a region becomes unavailable or goes down, and that never happens, your application can automatically just write to another replica now. So basically you have an RTO of 0 when you're building applications and using multi-master within Cosmos DB. In your applications, it's really very easy to use. The only thing you need to change, other than just downloading the latest SDK, is just use multiple write locations to true. The other thing you can do as well is there's another property within the connection policy. I should have shown the example here. But what you can do is when you deploy your application, you can feed it what the current region is it's running in. And then what we'll do, we have a collection of preferred locations built into the connection client for Cosmos DB. So if you set what region it's running in, so say it's running in East US or in Virginia or in West US, we will auto-populate a list of preferred regions within there that has essentially kind of an ordered list of the next available region. So if a region became unavailable and you send a request and then it basically did fail because the region was down or it was unavailable, we'll automatically retry that request in the next available region. So this is what I mean when I say there's really zero need for failover within here. Basically, everything is a failover all the time, right, or can be. I had a customer come and talk to me yesterday, and they were asking, how do I test this? And I went back to the dev team, and they said, well, you can't really test it. I mean, we don't have a way to simulate bringing down an entire region, which kind of makes sense. So I thought about this for a while, and I came up with an actual solution for this. So if you wanted to test failover for multi-master, the way you would do this is to go into the portal and then just remove a region within your application. And then just run a client that's just, I don't know, doing reads and writes against the database, maybe like every second it's doing a query against your region. And then just wait to see what happens. Because eventually what's going to happen is it'll then connect to the second region. And the only thing you'll notice is a little bit of latency because it's now got to travel to the next region over. So anyway, this is really, an amazing feature for us and really helps even strengthen the 5 nines availability for you and your applications. So, being multi-master, we need to provide some means for doing conflict resolution. And we've got 2 available means within there. Last writer wins, and then also a custom user-defined procedure. And let me go a little bit into each one of those. I'm very thirsty today. I don't know why, because it's so humid here. Maybe it'll be better when that hurricane gets up here. I'm hoping my flight doesn't get canceled actually later today. So, what's that? Yeah, flying back to Redmond, like around 5 o'clock or so. So the eye wall should be coming right over DC right around then. So first, let's talk about last writer wins. So this is the default means for doing conflict resolution in Cosmos DB. And here you can see in the portal, when I'm creating a new collection, in the settings thing here, I'm just going to select last writer wins. And then what I need to do is I need to specify a property within my document that I'm going to use to resolve it. So here you can see, and I've got a little box here, conflict resolver property. And then what I've done is I've specified a property, I'm just calling it user-defined ID. And the way this works is if I have 2 or more writable regions and I simultaneously write the same record or 2 records at the same time with the same ID in there and cause a conflict, I'm going to use that property right here, user-defined ID, to decide which one's going to win. So in this case, I've got a record, new contact, Scott Guthrie, and then I've also got Satya with the same user ID, or the same ID for the document coming in. And I've got to decide, okay, now which one's going to win. In this case, Satya is going to beat out Scott because his user-defined ID is 4 and Scott's is 3. The other, yeah, question?
Sorry, so are we responsible for coding in like auto-implement for the user ID?
So you can use any ID you want. If you don't specify an ID, we'll generate one for you. But if you generate your own ID, then this is a potential. So this is kind of contrived as an example, at least on an insert, because generally most people are going to use a GUID or some other thing that's going to be unique. So, I mean, one thing I want to point out is even with a multi-master or masterless scenario, conflicts generally should be pretty rare, right? But they can happen, particularly on like an update is where you might see a conflict, where you've already got an existing record in there, and then you have 2 regions simultaneously do an update to that record. Maybe it's an inventory database, so 2 people order something on 2 different sides of the world, and then you need to update the inventory database. Which one gets there first, or how are you going to decide who wins? You can use something like this, right, and then define the property. So which, I don't know, which customer or which anything within there. Or what you can do is not specify anything in there, and then what we'll do is we'll use the timestamp in there, which makes it truly kind of last writer wins, right? Because the higher the timestamp value, the later the record was written or updated. No, I wouldn't, right? So this is totally contrived and made up just for the purposes of illustration, right? So
if we define the ID to the property, then we're responsible for the logic to increment or whatever. But if we don't, then you just use a timestamp, which is time different.
Right, and to be clear, this user-defined ID, this is just a property. This isn't the ID on the document itself.
Right. So Is it just a numeric comparator?
Yes. Yep. Okay.
Yeah.
If you wanted to be true, just last writer wins, then don't put anything in here. We'll auto-populate this with the _TS for your document. And that's true, last writer wins. So, one more question.
What's the period of time in which two writes are considered simultaneous? Are they within a microsecond of each other, within 2 minutes of each other?
Yeah, so there's, the question is, when is a write considered committed?
Yeah.
Right, so it's after a quorum of replicas have replicated that data within the collection.
So it's not like multi-phase commit or like argument. So there will be some delay, right, between writing.
Correct, and it's local to the region. So here's what doesn't happen is it doesn't have to replicate to everything all over the world for it to be a commit. That would take too long and would blow up our SLAs.
Like financial institution, right? Like if there are some updates, like the typical banking scenario, an update could be the issue, right? Because the money is withdrawn.
It's generally, that's correct. So it's, I think you're generally, if you do have a conflict, it's going to be on an update rather than on an insert, right? It's rare to get them on inserts, particularly if you're using a unique identifier within there. So yeah, another question.
Do you catalog, or is there a place where you go and check all the conflicts to that?
That's an awesome question. The answer is, for last writer wins, we don't log any of these. So there's no conflict, there's no feed, or the conflict feed itself does not get any records in here. However, if that's something you want, then let me go on to the next steps here and I'll show you what we handle in those situations. So the next conflict resolution mode is a custom. And this one, you implement a user-defined procedure, which is basically a stored procedure, but it has a special signature. So within the portal here, just select the merge procedure custom, and then you enter in the name of the stored procedure that you're going to use to then resolve the conflicts within here. Now, this stored procedure is registered to the collection. So the only data this stored procedure can use is the data within the same collection. Now, here's an example of what a stored procedure might look like. And you can see this has a very kind of special function signature within here. And you have to implement this function signature for this thing to get called and work. And essentially, you can write whatever logic you want in here. I'm basically, in this example here, using the same user-defined ID to resolve the conflict. But this provides you additional functionality or flexibility for deciding how it is you want to resolve that conflict, whether it's an insert or an update within here. The other thing I want to point out too is with last write wins. So this is only used for inserts and updates. For deletes, if someone deletes a record and then some other region updates it, we don't do anything, right? So we don't bring deletes back from the dead. Basically, is what it is. So that we wouldn't handle that in that situation. So this is what happens for inserts and updates within here. And then one other thing I want to talk about is then there's actually kind of a third mode, if you will. And this gets to his question here, which is we have a custom mode where if you don't put anything in the stored procedure here, we won't do any conflict resolution for you at all. And what that means is we will then write all the conflicts out to a conflict feed, and then you can process those yourself. So essentially what that means is you would write another application or a little service and then regularly pull the conflicts feed and then read them in and then decide how you want to handle them. Now, this is more work, obviously, but it gives you a lot more flexibility because what you can do is, if it's its own app, you can essentially talk to anything in the world and figure out how do I want to resolve my conflict. You could go query another service, another database, another app, anything you want, and you can build all your logic within that app to decide how you want to resolve the conflicts. So, does that answer your question over there? Yeah. So this is what you want to do. If you want to be able to look at conflicts or be able to log them, you can do them this way. You could use the same logic that you had for last writer wins or any other method that you want to use to resolve it, but just do it within your own application, right? So one thing I'll point out too is we have a feature called change feed, which I'll talk about a little bit later, that kind of provides automatic notification when something happens, like an operation like insert and update within Cosmos DB, and it's used to build kind of Lambda architectures if you want to do, you know, like a hot path, cold path, or do some kind of Spark analysis, or do any kind of event-based programming. Conflict feed doesn't have that eventing capability within it, so whatever you write will have to go and like run on a poll to go and look at this thing. So, yeah, one more question.
About conflict feed, so does it mean that when we're using conflict feed, no any change in database happens at the conflict point? Yeah, so this means that we got two conflict feed updates. We'll just go to the feed and no updates happen on the database.
So something's going to get committed, but the other thing's going to be the conflict, right? So let me show you here. So I had a little picture of this thing. So here is what a conflict might look like in an update, right? So I've got the current document. This is the guy that's committed, and then here's my conflict sitting right here, right? So, and actually, when we write out to the conflict feed, you can actually go into the portal and look at them in here. Now, currently, you can't really do anything with this in here. I actually asked the dev team if, hey, it'd be nice if customers can actually go in here and just select whether or not to update the original with the conflict in there or just get rid of it. So I think they're gonna provide that capability in a future build for the portal on this thing. But for right now, this is just a place where you can kind of look at them within the portal if you want.
What specific record will be used? So is it kind of latest version or something like that? So what record will be added to the database? So we have a conflict, yes. So this conflict, yes. So one of that region should be executed, yes, and another one should be fixed conflict. So which one will be?
Yeah, so it's because it's matchless, it's kind of non-deterministic, if you will, right? So I can't really tell you which one's the one that's going to be the actual committed record in there versus which one's going to be the conflict. It just kind of is what it is. It's, I guess, whoever gets the core and faster, I guess, within there. So, I mean, just keep in mind, I mean, this is rare, right? I mean, we're going to replicate your data in milliseconds globally around the world, so getting conflicts should generally be a pretty rare occurrence. But they do happen. So that's why we're providing multiple ways of being able to resolve those things, from simple using a last writer wins type policy to completely custom, build your own, however you want to handle it. The most complex business logic on the planet possible, you can do it that way too. So, question in the back.
Is there any way you can be a digital record more than one successful that way? Really compare all three?
The original record. So the original.
So these two had a conflict. Prior to the first successful update, was the original status. And if you compare all three, it's kind of like a K-3 comparison. You understand which differences were new and which differences are just the current document updated the region, but really that Southeast Asia was not updated. In other cases, updated something else.
No, we don't have that capability. So you're going to have, one's going to get committed and the other one's going to generate a conflict. Right? Now you can have multiple conflicts. So if I had multiple regions, let's just say I had 4 regions, and 3 of them did an update on the same record, I can have an original one that committed, but then I can have multiple conflicts from that. So what I would see is the same record here each time, and then multiple conflicts listed in here. But we don't have, I mean, the only way you could have anything like that is if you baked in using our change feed, and then kind of build a kind of Lambda architecture where you're kind of feeding that into something else. But that's, you then go and then you could go and look at a prior instance of that article. We get that too, like document versioning is another question we've got. We don't provide any document versioning, but you could actually build your own using something like a change feed, right? So any operation, any insert or update on that thing triggers a change feed event. Go write that off into another log, right? And then put a version stamp on it. And then you could go back and look at all the old versions of that document. So you could implement something like that, but we don't provide something like that out of the box.
Well, the only way you get this kind of conflict is if you're getting your default last write wins enabled, is if the timestamps were the same. Otherwise, it would never be a conflict.
Yeah, so I get that question too. If the timestamps are the same, one document, one document is going to win.
You just pick one.
It's just Yeah, and again, that's kind of non-deterministic.
So this would never occur here. Then. It would back being enabled. You would never get an actual conflict law.
Yeah, you would never. Well, with last writer wins, we don't log any conflicts. We just handle them and it's done. Yeah. The only way you're going to get a log conflict is if you turn off. If you basically.
It would be unlikely but possible.
If you use this method here.
Yeah, double timestamps.
It's not likely, but yeah.
In which case, they just pick a one. So.
That's correct. We're just going to pick a winner. It's non-deterministic, as devs like to say.
So, are these different options for conflict resolution configurable per table, or is it for your entire Cosmos?
By collection. Yep.
And I was holding a question for later, but this is kind of relevant. I'm interested in the strong consistency model. What does that actually mean? Let's say you have 5 regions enabled. Does strong mean that what that data has been written across all 5 regions?
That's correct. Correct.
Okay.
Right. Which is why it has a huge impact on latency, availability, and throughput, because you have to get a quorum now across all those different regions. So I write a record in West US, and that region's not going to be available until it gets all the way to, say, Singapore or North Europe or wherever it is, and all those things have to happen. So this is why you should play with it. Let me put it this way. There's very few customers of ours that use strong consistency within this. They tend to use session, right? Because they want to be able to read their own writes from the application endpoint that's connecting to that instance of Cosmos DB. A lot of them, in some cases, eventual is really good. Bounded staleness is probably second in terms of that. So I'd say about 70% using session, and then about 20, a little more than 20% using bounded staleness.
So, yeah, I'm a little just confused about the unit of work in the table. So if I have a unit of work that includes 3 updates, and the same unit of work takes place in 2 different locations, and the first 2 are done at 1 timestamp, and the third one is done where the other transaction has a faster timestamp, am I going to end up with like half the tables updated by 1 transaction and the other half updated by a different transaction, even though they're 2 different transactions with 2 different people? You see what I'm saying?
Struggling. So you've got a single
So 2 different
record.
The debit by this guy, debit, credit, debit, credit. This debit takes first over here, and then the credit, and the other one, the credit takes first. And it ends up that you end up with a debit from this guy's account and a credit from this guy's account because this guy was a little faster on his debit and this guy was a little faster on his credit. You know what I'm saying? You're updating the same account with like last update kind of thing. And it just so happens that this guy did his first transaction faster than the other guy, and this guy's second transaction was 8 microseconds faster than the other guy's. So you're going to end up with like
So what I would say is the design doesn't sound right to me. You should do that in a single operation.
Right. So then the timestamp should be at the unit of work or the commit.
If you're writing to a single record or a single item within Cosmos DB, you should do that with basically with an atomic piece of code, right? 1 single request. Right. So do it.
But you got a debit and a credit.
Call replace.
Those are two different table entries, 2 different records. You got debit entry and credit entry, to a different account.
Right. So we don't
Credit
support.
cash, debit.
Is your question? Do we support transactions?
Yeah, kind of. You support transactions.
No, we don't support transactions.
Oh.
So we do within the single. We do within a single operation or collection right there, but we don't have a thing where you can go begin transaction, do a bunch of work, and then commit transaction.
Okay.
That's not supported.
Commit rollback.
No, it doesn't.
rollbacks.
It kind of this kind of blows up once we start let's put it this way: we don't put locks on anything in Cosmos DB, and that's how we guarantee kind of the single-digit latency and the high availability.
Yeah.
We don't block anything that goes on within there. So this is something you would have to build into your application, right? It's when you've got everything together, jam it into Cosmos DB, and we'll do that in less than 10 milliseconds. Yep. No, I'm going to kill the demo because we're just taking it up with questions.
Doing a POC and I see some numbers there. There was talk about having on-premise emulator for that.
We do it actually. We have an emulator available. Supports all the data models that we support in Cosmos DB. You can get that and download it. I'll send you, or I'll just show you where you can get that in there. We strongly encourage customers to do their prototyping and testing using the emulator first, because it doesn't cost anything to do it. You can also get query statistics, so RU usage for the queries that you're running in there as well. So it's pretty well instrumented. And I would definitely recommend people use that.
One last question.
Sure.
Speaking of cost, I noticed that in your multi-master part, there's a checkbox to enable multi-master. Is that because there's a cost difference between using it and not using it?
There is a cost difference for multi-master. So now, basically, you're going to write to multiple locations everywhere, whereas versus before you were writing to a single location. Writes are going to cost you more than reads. So yes, multi-master costs more to run than it would if you were using the single master or not enabling it. Okay, all right. I'll talk about costs and other stuff a little bit later. We're doing some good stuff around the cost end of things. So custom asynchronous, so kind of here's what it would look like if you were going to process this right here, and you can kind of write a case statement. So I want to handle my inserts differently than my replaces. For the deletes, obviously here, you know, if you want to bring a record back from the dead, I guess you could. I don't recommend it. And then as you process those, you can then go and then just delete the conflicts after it's processed, and then just move on to the next one within there. So let's do a demo. Okay, so actually, let me back up. So what I've got is I have two Cosmos DB accounts created here. I've got a single master account, and let me give you a look on that. So this account has a single write region in Southeast Asia, and then I have two read regions. I've got one in West US 2 and one in North Europe. So my scenario here is I'm a company, I'm based out of Singapore, I provision my account here, and we've added customers in different parts of the globe, so we're replicating out now to the West US and to North Europe. I now also have a multi-master account. So within here, I'll click on this, and you can see the difference. I've got the same regions here, Southeast Asia, West US 2, and North Europe. The difference here, of course, is I'm read-to-write enabled on both those regions. So let me go back. And what I want to show you is I've got an application here. So this application is just a VM, and it's set up in West US 2. And I'm going to contact and talk to my Cosmos DB database that's located there in West US 2. So I just want to run some latency tests just to give you an idea of what's going to happen. So here, I've got a single master, and I'm going to do some read and write latency testing. I've got three regions set up in this order. So I'm using the preferred locations collection within my connection policy, and I'm going to prefer to start with West US 2 for doing all my reads, and then I'm going to go to Southeast Asia, and then to North Europe. So if any of those become unavailable, that would be the order of failover within my application. So here's what I'm going to do. I'm going to test 100 reads against region West US 2, and let's just see how that goes. And as you would expect, this is super fast because my application is located in the same region, and we're doing mostly single millisecond reads from that location. So now what I want to do is I want to test a write. So I'm going to test 100 writes in this application, and as you would expect, these are going to be quite a bit slower. And the reason is my application in West US 2 now needs to traverse Azure's backbone and then go all the way to Southeast Asia and then do the writes. And it's going to do 100 of those, and that's going to take a little bit of time. Yep, and there it's done. So there you can see around 170, 180 milliseconds for each of that. So now with multi-master, I'm going to do the same test. So I'm going to create a document client, and I'm going to call the same, configure the same exact way, West US 2, Southeast Asia, and North Europe, and let's test 100 reads, and as you'd expect, that's going to be fast as it was before. Now, let's test 100 writes. And whoa, that's super fast. Did you catch it? So now I just did 100 reads or 100 writes against West US 2, and that, of course, is now blazingly fast, right? How is that possible?
Yes.
I've now replicated my database to be write-enabled in every region that I've configured it.
You still have to actually do the write process.
No, we replicate on the back end. So you write to your local database, we replicate that in the background. Any other questions about that awesome demo?
Yes.
It is awesome, isn't it?
It is.
Wait, question? You basically talk to a single global endpoint within Cosmos DB. The only difference is you set your current location. So how I configured this in the demo is I set a preferred, we have a preferred locations collection within the connection policy, and I can set which order I want within there. We actually have a new feature now available in our SDK, so all I have to do when I create a new connection client is just set the current location within there, and then deploy that with my app. So if I have an app in WestUS 2, then I'm gonna just, you can ship this in the config file, right? So send the same bits, deploy each of the same bits to each of your locations, and then just the config difference is gonna be what locations it's running in. And what you do is if you set current location inside the connection policy, we will then auto-populate all the preferred locations that you're running in. And then the nice thing about this is that we've already figured out the latencies between all the different regions. So if I'm in West US 2 and East US and Southeast Asia, and I'm deployed in West US, and I set my current location to West US, we will automatically pre-populate it to run in West US, and then go to East US, and then go to Southeast Asia. See what I'm saying? So that's the only thing you need to do is just set current location for whatever region it's running in. We'll auto-populate what your failover regions are. And so if a region becomes unavailable, we'll just automatically retry that same request into a separate region. And the only thing you're going to notice is difference in latency. But you're not going to lose any data. Cool? All right, let's do some conflict resolution. Now, what I did is I built a little app, and I can show you where this is available. Our devs wrote a conflict generator. And I want to point out this is actually really tricky to do, and it doesn't always work because generating conflicts, as you might suspect, can be tough. So what I've got here is I've got an application, and what it does is it connects 3 different Cosmos DB clients to 3 different locations. And then I stick those all into a collection, and then I execute them all on separate threads, all simultaneously. And each of them is going to, in this case, do 3 inserts in 3 different regions at the same time with the same ID, and try to get 1 or more of them to commit so that I can generate a conflict on the back end. So let's try this. So I'm going to insert a document with the same ID in multiple regions. Let's see what happens. So here I've got 3 documents. So it's got the ID of 955, Scott Guthrie, and Redmond. And I've got 3 different user-defined IDs. So I've got a defined ID of 4, 2, and 0. So in this scenario here, I'm going to use last writer wins to resolve the conflict. So let me go back and show you in my database what this is going to look like. So let me go to my multi-master database. So here this is what I did the latency demo out of here, this contacts database. So here I have last writer wins. And within here, you can see I've selected last writer wins as my conflict resolution mode, and then user-defined ID as my conflict resolver policy. So I just did 3 inserts with ID 995 with 3 different user-defined IDs. Let's go in here and see which one won. So here, so this is user-defined ID 0. So what this tells me is I actually did not generate a conflict because this one replicated faster than the other writes happening. So let's try it again. So here I'm going to generate another. This is ID 761, and then I've got user-defined ID of 0, 4, and 7. Now let's go ahead and take a look. And I want to refresh this. Okay, that one actually generated a conflict because user-defined ID, which was committed in North Europe, actually won the conflict. So generally speaking, West US 2 should win, but I'm executing all three of these at the same time. And here what we see is I actually had a conflict, and this one is the one that won, the one that I committed in North Europe. Cool? Easy, right? I know. No more conflicts ever. Okay. Let's try a little different demo. So what I'm going to do, let me say no here. So now I'm going to do an update. So this is going to be against a collection. How am I doing on time, by the way? I'm at an hour right now, so 50 more minutes.
You stop at
10:50? Okay, let me go super fast. So here I've got one other collection, and this one is set up for manual. So I've selected merge procedure custom, but I didn't supply any stored procedure. So what's going to happen is any conflicts are going to end up in this conflict feed right here. So let's see if we can generate a conflict. So I'm going to create a new document with ID 730, and then I'm going to do 3 updates in 3 different regions. And let's just see if that generated a conflict. Nope. All right, let's try it again. All right, insert a new record, ID of 60, and then we'll do 3 updates on that. And here we go, I've got some conflicts. So here we go. So I've got my ID of 60, here's the current document, this is the one that was committed, and then here's my conflict update. So this went into West US 2, and then this one went into North Europe. And here you can see, here's my current document. This is the one that was committed in Southeast Asia. And then I generated 2 conflicts out of this thing. One in West US 2, and another one in North Europe. Cool? You can clap. Yay! I generated conflicts. It's really super hard. So, okay. All right, back to slides.
How do you resolve it? Sorry.
How do you resolve it?
Yeah.
So what you would do is just either write an application, right, to read and pull against the conflict feed, right? That was the thing you just saw on the screen right there. It's basically just a rendering of what's in the conflict feed, and then you decide how you want to handle it. Right?
You can't do it from the GUI though. You have to.
Right now, you can't do it from the portal, but this is something I've asked our dev team to look at in case customers want to be able to just pick which one should be the winner within there. But right now, you would do this in an application. Okay, so let me quickly go through some recent updates. So at Ignite 2 weeks ago, we announced the GA of our Cassandra API. So now Cosmos DB can provide a fully managed database as a service for Cassandra. No need to manage clusters or nodes. All the other heartache involved with managing Cassandra is all gone. You can use Cosmos DB to do this. Still same single-digit latency, 5 nines availability, support for Apache Cassandra 3.11, and CQL binary protocol version 4. We have a new JavaScript SDK. So this was completely rewritten from the ground up using TypeScript. Has support for promises. We introduced a new object model in here. If you're familiar or have used Cosmos DB, you have to use this thing called a URI factory to get references to objects within Cosmos DB. So we have a database URI, a collection URI, a document URI. This does away with that entirely. So when you're going through and programming your applications, it's databases.database ID, .collections.collection ID, so on. So much cleaner. We're going to replicate this kind of object model across all of our SDKs, including our .NET SDK. And in fact, we just announced last week that once we're done updating that, we're going to open source our .NET SDK as well, which is cool. You can now go and see how we've implemented that SDK, and we're going to look to do that for all of our SDKs within there. This, of course, supports multi-master, like all of our SDKs do now. On the pricing front, I want to let you know that we now have the ability to do reserved capacity with Cosmos DB. This works just like reserved instances or reserved capacity for VMs. you make a commitment for 2-3 years for RUs. The longer you go and the higher the RUs you reserve, the deeper the discounts, all the way up to 65% off list price within there. So after you've done your dev and your test and you're like, okay, we're bought in on Cosmos DB, definitely this is something you should explore to get the deepest discounts possible for your Cosmos DB usage. Yep. Also on the price point, we now have a lower entry point for databases. Prior to this, you had to provision 50,000 RUs per database. You can now do this starting at 10,000 RUs. The other thing I want to point out too is you can also share RUs across collections. So let's just say you provision 10,000 RUs for a database. You can say collection 1, I want you to have 2,000 RUs out of that 10K, and then the rest of you collections can share the other 8. So this is nice if you have collections that are particularly going to need more throughput. You can just carve those off and then let the other collections just share amongst themselves. So a little more way to get more efficient, more prescriptive about how you're using your resource usage within Cosmos DB. We also have lots of free options. So you can go and sign up for a trial account. You can also go and sign up for a free Cosmos DB account. So this is different. You can go to akams/try-cosmos-db and just provision a Cosmos DB account. We'll keep that up and running for you for 30 days. You get your own key, your own URL, your own key. You can try it for 30 days. We also allow you to extend this, so you can go in and extend that if you want and run that longer than 30 days. Also, the Cosmos DB emulator, I want to point that out. That's very handy for doing local testing. You can also run this in a Docker container, Docker for Windows container as well. And then deploy that, so you can also run that as well. We have scripts online in GitHub for how to set that up. I want to point out all of this where to learn more. I've got a minute.
Will you be posting your slides online and the website?
I can. They're freaking out. Oh, I'm going to post all my stuff online. So let me go even faster through these things, so you have no chance to write them down. Where I would start is with our docs right here. We have a really killer section on concepts that's really super important to learn. Let me just show you kind of quickly. If you go to our documentation here and then go to concepts, I would strongly recommend you go through and read each of these in here. We talk about how we do replication and multi-master in here, how we manage throughput, how to get and set throughput, partitioning, indexing, consistency models, change fee, TTLs. There is a ton of really deep information to conceptually understand how we built Cosmos DB. All the multi-model API support is in here, so you can get examples on how to get started with all this stuff. We show the support levels for each of the different models that we support in here, including Cassandra, Gremlin, and Mongo. And then, again, I just want to point out, we've got all of these SDKs out on GitHub. All of these have samples within them. In particular, I want to point out with our .NET SDK, we have an interesting folder in here called Patterns. So if you're interested in learning how to handle things like time series or do event sourcing, lots and lots of very interesting samples in here. We also have examples that show you how to build kind of test harnesses for your application, so how to measure RU usage, how to measure latency. The sample you saw there where I was doing multi-master and then counting off the latency between there, it's just a very simple application with a stopwatch on there, but we have examples fully built out, also calculate RUs for you, and also at what percentile as well within there. So I think that's it, and I can't believe it did fly by. So anyway, that's it. Thank you very much.
All right, folks, we got a